Alright, so today I'm going to model how to do question number 1 on topic C, residuals, and just remember that our general guiding principle is what does the residual tell us about the relationship between the two variables. And as a quick reminder, the residual is the distance between the actual data point, so remember this is an actual data point, and the regression model. Right, so this is the regression model. And the regression model predicts outcomes. Okay, so it's the distance between an actual data point and the predicted outcome. So let's read through the problem. Juan decided to collect data from 13 different animals and complete a statistical analysis of the results. He wanted to know, is there a relationship between a mammal's longevity and gestation time? So quick vocab check. Longevity means the typical lifespan of an animal. So how long an animal lives. Gestation time is the typical time between conception and birth. So how long an animal is pregnant. All right, so let's go ahead and get started. What does the problem 100, 15 mean in context of the problem? When you see in context of the problem, this tells you to use the real world variables to describe. So instead of saying something like x is 100 and y is 15, instead we say x is, so this is the x-axis, so x is gestation time, and y is not y, but longevity. So if 100 represents gestation time and 15 represents longevity, what this means is something like, we're talking about animals, right? So an animal that has a gestation time of 100 lived for 15 years. An animal that had a gestation time of 100, the unit is days, lived for 15, the unit is years. All right. So part B says a lion has a gestation period of 108 days. So estimate using the regression model, so the line on the graph, how long a lion might live for. And so what we're going to do, it says using the line on the graph. So remember, this regression model predicts outcomes, and we want to predict the outcome for 108 years, or 108 days. So 108 is just past 100, and you want to go and essentially interpret this coordinate here. So this is 108, and let's see, it's not 10, and then I gotta say this is 11, 12, 13, 14, 15, yeah, and it's not 11, so maybe I'll say like 10.7. So, how long the lion might live for. So you might start the sentence as like, using the regression model on the graph, I predict, and again, this is a prediction because we're using the regression model. I predict a lion with a gestation period of 108 days, lives for, what did I predict? 10.7? 10.7 years. So some key words or key things that I said in this is, first of all, I stated what I was using. So I said using the regression model on the graph, and I also said I predict. So it's important to note that if we're using the regression model, we are coming up with a prediction. Okay? Question C, calculate, using the regression model, a more accurate prediction for how long a lion will live if they have a gestation period of 108 days. So this time I'm going to use the regression model equation. So let's take a look at the graph again. The equation is up here on top. So I'm going to use that equation to calculate the longevity. So I'm going to record it down here. Y equals 0.04x plus 6.648, and I just copied that. I'm going to show that I'm going to substitute in 108 for x. And then I'm going to go ahead and use my calculator, and I get 10.968, which is pretty close to my estimation. So I'm going to go ahead and write a complete sentence here. Using the regression model, I predict a lion with a gestation period of 108 days lives for 10.968 years. All right, again, notice I have my math and I'm saying what I'm using. I'm using the regression model, and this is a prediction. Okay, question D, what does a positive residual mean in context of this problem? Okay, so a positive residual, mathematically, a positive number comes from, like, say, 10, 11, 12 minus the prediction, which is 9. 12 minus 9 is a positive 3. So this residual, for example, is a positive 3. This residual is approximately, let's see, 1, 2, 3, 4, like 4.5 is the residual for this one. This one has a residual of 1 to approximately 3. This one has a residual of approximately 1, 2, 3, 4, 5, 6. So what does it mean that a residual is positive? Number one, it means that the actual data point is above the prediction. So step one, what does a positive residual mean? It means that the actual data, I'm just going to make a note, actual data is above the predicted outcome. Okay, and so now I need to say in context of the problem. So in context of the problem, remember, when I say context, it means I need to use the real world variables. And so what it means, if we look at our graph, is that it's higher, right? So the longevity, so how long the animal lived was greater than how long we predicted. So say we predicted that this animal would live for 9 years, and this animal actually lived for 12 years. Here we predicted the animal would live for 10.9 years, and it actually lived for 15 years, right? So what it means is, I'll say considering, and I'll state the math first. The residual is positive this means an animal, meaning a real data point, lived longer than than the regression model predicted. Okay? All right. Part E, what is the value of the residual for the data point 100, 15? What is the value of the residual for the data point 115? So if I'm calculating residuals, I'm going to make myself a little chart. So the chart would be X, which is gestation time, Y, which is longevity, and then predicted longevity and residual. So X is 100, Y is 15, and I'm going to go ahead and calculate the longevity, the predicted longevity for 100. So it would be Y equals 0.04 times 100 plus 6.648. I use my calculator, and I get 10.648. So 10.648. Calculate the residual. I take the longevity minus the predicted, and I get 4.352. So considering the residual is 4.352, this means an animal lived specifically 4.352 years longer than the regression model predicted. All right, last one, question F. Do you feel there's a relationship between mammals and longevity and gestation time? Reference the values of the residuals in your answer. All right, so if I look at the graph, and again, these are all of these residuals that I have here, these are all estimations. It's like a positive 5. So this would be like a negative 2. This is a negative 1, 2, 3, 4. This is a negative 1, 2, 3, 4, 5, 6-ish. This is a negative 1, 2, 3, 4, 5. Negative 1. Negative 1, 2, 3. So what these residuals mean is that the predicted values, right, are here, and what actually happened are all here. So this animal lived 3 years longer, this one lived 4 years longer, this one lived 6 years longer, this one lives 3 years longer. This one was 2 years shorter than what was predicted. This was 4 years shorter than what was predicted. This was 6 years shorter than what was predicted, 5 years shorter than what was predicted. So generally speaking, I think that the regression model, I think there is a relationship between gestation time and longevity, but I don't think it's a very strong relationship because the prediction is not super accurate. It's like off by 3 to 6 years in either direction, right? Not a lot of their predictions are close. There's maybe like one data point that's close. So to summarize, I feel like there is a relationship. I'd say like considering the graph is positive, there is a relationship between gestation time and longevity. Specifically, and I'll elaborate on that, as gestation time increases, longevity increases. I will add on, however, considering the residuals are around +3 to 6 or -3 to 6, right? They're like plus or minus 3 to 6 years. It is not a very strong relationship.